This question was asked in GATE 2004 Electronics and Communication. A plane electromagnetic wave in free space incident normally on a lossless non-magnetic dielectric material. It has permittivity greater than that of air. The maxima and minima are observed when the electric field, this is electric field E, is measured in front of the slab, and the maxima of electric field is found to be 5 times the minimum field. What is the intrinsic impedance of the medium? We will quickly draw this. So, non-magnetic dielectric material, here we have epsilon, which is greater than epsilon naught. Here the permittivity is epsilon naught, and it is found that when the maxima and minima is measured, we have found out that the maximum electric field here in front of the slab is 5 times the minimum electric field. So what we are given here is the standing wave ratio is, which is Emax by Emin, is 5. Now from this standing wave ratio we can find out the value of intrinsic impedance. How? So we have to find out what is the reflection coefficient, and from the reflection coefficient we can find out the value of eta. So let's see how to solve this. So S is given as 5. Now from this we can find out the reflection coefficient gamma, as we will get the modulus of gamma as S minus 1 by S plus 1. That is 4 by 6, that is equal to 2 by 3. Now this is the modulus of gamma, so the value of gamma can be plus or minus 2 by 3, but here it is clearly given that the permittivity of medium 2 is greater than that of medium 1. So the correct value of gamma when the medium 2 is greater in permittivity is plus 2 by 3. So we have found out the value of gamma. So gamma is plus 2 by 3. Now we need to find out the intrinsic impedance. We know the expression for reflection coefficient. So the expression for reflection coefficient is, for a normal incidence, eta 2 minus eta 1, that is the difference of intrinsic impedances of the medium by their sum. So this we know as 2 by 3 equal to, we know the value of eta 1, where eta 1 is the intrinsic impedance of free space, which is 120 pi. Now from this we can find out what is the value of eta 2. That is 2 eta 2 plus 2 eta 1 equal to 3 eta 2 minus 3 eta 1. That leaves 2 minus 3. This minus eta 2 equal to minus 5 eta 1. So the intrinsic impedance of medium 2 is 5 times that of medium 1. So that will be 5 into 120 pi, which gives 5 into 120 is 600 pi. So the correct answer is option C.